Hello guys, in previous lecture we will show the three preparation methods of alcohol from alkene. These three preparation methods are important preparation methods for our board exams, our competitive exams, in that JEE, NEET as well as CET. In these reaction, there is a little bit difference between reactant and product, or as well as a reagent. Then by using this reaction, we compare all these three examples, or all these three alkene, all these three reactions while the preparation of alcohol from alkene. In this first reaction, we can say we will see the hydration of alkene. Second reaction is a oxy or a hydroboration reaction, and third reaction, it is a oxymercuration and deoxymercuration reaction. Okay. In this oxymercuration and deoxymercuration as well as hydroboration, and after that a hydration of alkene. We plot the table. The first column is a serial number. After that name of reaction or name of methods of preparation of alcohol methods, and this is a result or a remark. Okay, this is a table is plot here. First reaction, it is a hydration of alkene. Okay. In this hydration of alkene, we will show the reaction is carried out by using a cold concentrated H2SO4. It undergoes hydrolysis. That means this return is in form of H plus and H2. Also we can return in the form of H0 plus. Okay. Hydration of alkene. The hydration of alkene, it is a direct addition of water molecule. In this reaction, the addition of water, it is in direct form because there is a formation of carbocation. After formation of carbocation, carbocation is considered as an intermediate. After formation of carbocation, the water molecule, that means this oxygen, is attached on the carbocation. After attacking of this oxygen on carbocation, there is a formation of protonated alcohol. There is a formation of protonated alcohol, and after that there is a deprotonation step. After that there is a deprotonation step. Okay, that means in this reaction there is a direct addition of water. Okay, then second step is a second important thing is a formation of carbocation. After formation of carbocation, there is a rearrangement reaction possible, but in this case we can see the 1,2-methyl or 1,2-hydride shifting. Okay, these two important factors we will study in the mechanism of this reaction. But depending on these two factors, the two factors are more possible for the stability of the carbocation. That means the carbocation, it is a main intermediate in this reaction, and after formation of after formation of stable intermediate, after formation of carbocation, then 1,2-methyl shift and 1,2-hydride shift is formed or possible. By this methyl shift or hydride shift, we can consider a rearrangement reaction. Therefore, in this reaction, the rearrangement is possible. There is a rearrangement reaction is possible. Then next point is, in case of hydration of alkene, the hydroxyl group is attached to the double bonded carbon atom, but this attachment or this addition of hydroxyl group is according to its Markovnikov's rule. According to Markovnikov's rule. By using Markovnikov's rule, the hydroxyl group is added. Okay. These are the some important points in hydration of alkene. These are the some important point in hydration of alkene. After that, the second reaction, it is a hydroboration reaction. Second reaction is a hydroboration reaction, HBO. Okay. In HBO, the symmetrical alkene as well as asymmetrical alkene we can take here by using this reaction. There is a addition of hydroxyl group by using a BH3 in presence of PHF. PHF is used as a solvent, or instead of this reagent we can use B2H6. It is a borane and this one is a diborane. Okay, out of these two reagents, one reagent we can use for the preparation of alcohol in case of hydroboration reaction. Okay. After that, after hydroboration reaction, we can use a peroxide in presence of base. In presence of base, the base, instead of base we can use a dilute NaOH. Okay. Then the conclusion of this reaction. In this reaction there is a addition of hydroxyl group. That means addition of OH group or addition of water molecule. Okay, water molecule is considered here instead of hydration of alkene. In hydration of alkene there is a direct addition of water molecule, but in this reaction there is a no direct addition of water molecule. That means it is an indirect addition of water. Indirect addition of water. Why indirect addition of water in this reaction? Because from BH3, the boron shows the partial positive charge, and there is a formation of, or there is a 3 hydride atoms are attached to this boron. There is a H minus, H minus, and H minus. That means this H minus from the water molecule. Out of these water molecule, two hydrogens are here. Out of these 2 hydrogen, 1 hydrogen comes from the hydride. That means BH3 gives the H minus ion. That means hydride. Okay, and remaining hydroxyl group, H minus comes from the H minus comes from the BH3, and remaining OH minus coming from the peroxide. This peroxide then it forms the 2 hydroxyl group. Okay, therefore one H minus is coming from the BH3 and another OH minus is coming from the peroxide. Therefore, in this reaction there is an indirect addition of water molecule. Okay, in this step, BH3 gives H minus and OH minus gives peroxide. OH minus from peroxide. Okay. Therefore, in this reaction, indirect addition is shown. Okay. In this case, if we can use the asymmetrical alkene, in this case we can use the asymmetrical alkene. The asymmetrical alkene is reacted in pH in presence of THF, then it forms trialkyl borane. Then again it is reacted with peroxide in presence of dilute NaOH or in presence of base. Then alcohol it forms. But alcohol, in case of alcohol, the alcohol is prepared from unsymmetrical alkene. Then this reaction is proceed. That means when unsymmetrical alkene is reacted or it undergoes HBO hydroboration reaction, the addition or the alcohol it should be formed according to anti-Markovnikov's rule. Anti-Markovnikov's rule means the doubly bonded carbon atom, the hydroxyl group is attached to the doubly bonded carbon atom, which contains a more number of hydrogen atoms. Okay. Therefore, according to anti-Markovnikov's rule, there is a formation of alcohol. Okay. Then, in this reaction, there is no formation of carbocation. There is no formation of carbocation. Therefore, in this reaction, the rearrangement reaction is not possible. In this reaction, the rearrangement reaction is not possible because it does not form carbocation. Okay, this is a second preparation method of alcohol from alkene. It is a hydroboration reaction. Okay. Then after that, the third reaction is OMDM reaction. That is OMDM reaction means oxymercuration and deoxymercuration reaction. The reaction is a OMDM reaction, that is oxymercuration and deoxymercuration reaction. Okay. In this reaction, we can use symmetric as well as unsymmetric alkene. By using this type of alkene, we can use a mercuric acetate plus water plus NaBH4. Okay. In first case, there is a addition of mercury. After addition of mercury, it undergoes hydrolysis. There is a formation of, or there is an addition of water molecule of carbon atom. But this water molecule is added in this reaction or added in the alkene is in the indirect form. That means addition of water is indirect addition of water. That means from this water molecule, the H minus comes from sodium borohydrate, because this sodium borohydrate is also act as a reducing agent, and because of this reducing agent, it donates the H minus and it donates the hydride to the electron division species. Okay. Then OH minus comes from the water. This water gives the OH minus ion. Because of these two reasons, in this reaction, the addition of water is indirect. Okay, these 2 points are written here. The H minus comes from the NaBH4 and OH minus comes from the water molecule. Okay. Then, if we consider the unsymmetrical alkene, that is CH double bond CH2 CH3 CH double bond CH2. It is a propene. It undergoes OMDM reaction. Then it forms the alcohol, but alcohol formation is according to which type of Markovnikov's rule, that is anti-Markovnikov's or Markovnikov's rule. But in this case, the alcohol is formed according to Markovnikov's rule. That means the hydroxyl group is attached to the double bonded carbon atom, which carries less number of hydrogen atoms. Then it forms CH3 CH OH, and then CH2 get converted into CH3. That means the second important point, if we can take the asymmetrical alkene, then alcohol is formed according to Markovnikov's rule. Okay. Then in this reaction, there is no formation of carbocation. Therefore, in this reaction, there is no rearrangement reaction or rearrangement reaction is not possible. But in the we explain during the mechanism of this reaction, C plus I will return it. But this C plus, I will say that this positive charge carbon atom or this positive charge on the carbon atom is not belongs for long time. Therefore, this is a positive charge is automatically disappear because the bond making between carbon and mercury and carbon it happens in fraction of second or instant time. Therefore, this positive charge is a not stable positive charge. Therefore, in this reaction the positive charge is not considered on the carbon atom. That means the carbocation does not form. Therefore, no rearrangement reaction is shown in OMDM reaction. Okay guys, this is a comparison between hydration of alkene as well as hydroboration as well as oxymercuration and deoxymercuration reaction. By using this table, we can solve easily some questions by using this comparison. Okay, then some examples we can take here. Consider propene CH3 CH double bond CH2. This is an unsymmetrical alkene. This unsymmetrical alkene, firstly, the product of this unsymmetrical alkene is carried out on the basis of hydration of alkene. Hydration of alkene, in this reaction we can use a cold concentrated H2SO4 and water molecule. It undergoes hydrolysis. Okay. Second one is a hydroboration reaction. In this BH3 in presence of THF or B2H6 is used, as well as peroxide in presence of base we can also use for the preparation of alcohol. And third step, in this third reaction there is a oxymercuration and deoxymercuration reaction. In this, the mercuric acetate, after that it undergoes hydrolysis. After that it undergoes the reduction reaction by using sodium borohydrate. Okay, these two reactions, by using these three different reactions, you can write the product of this reactor. Okay. But we know really this cold concentrated H2SO4 it undergoes hydrolysis. This product is formed according to Markovnikov's rule. This reaction anti-Markovnikov's rule, and this reaction is followed by also Markovnikov's rule. Okay. But in this reaction there is a rearrangement is possible, and in these two reactions there is a no rearrangement reaction is possible, because in this reaction there is no formation of carbocation. In this reaction there is a formation of carbocation. Okay. After formation of carbocation, there are two types of carbocations are formed. The positive charge is present on this carbon atom, therefore this is a primary carbocation, and if the positive charge is present on this carbon atom, there is a secondary carbocation. That means the two carbocation intermediates are formed, then these two carbocation intermediates is right here. This is a CH3 CH plus CH3. This is a secondary carbocation, and then it is a CH3 CH2 plus there is a primary carbocation. These are the two intermediates are formed here. One is a secondary carbocation, another one is a primary carbocation. And secondary carbocation is more stable than primary carbocation, as well as the product is formed according to Markovnikov's rule. That means the OH one is attached to this carbon atom, and then it forms the major product. That means the CH3 CH OH and then CH3. This is a major product. Okay, and this from the primary carbocation, the OH minus attacks on the primary carbocation, then it forms a CH3, CH2, CH2 and OH. That is a minor product. Minor. Okay. In case of hydroboration reaction, there is a no carbocation is formed, therefore then in this reaction no rearrangement reaction is possible. Okay. Then this product is formed according to anti-Markovnikov's rule. That means the hydroxyl group is attached to the carbon atom which contains more number of hydrogen atoms. Okay. Then product is CH3, CH2, CH2, OH. Okay. This is a one product is formed. In case of OMDM reaction, this reaction is also continued according to Markovnikov's rule, and there is a formation of Markovnikov's rule. That means the hydroxyl group is directly attached, or hydroxyl group is attached or bonded in between doubly bonded carbon atom which contains less number of hydrogen atom. Therefore, the hydroxyl group is attached to this carbon atom. Then it forms a CH3, CH, OH, and this is a CH3. There is a formation of secondary alcohol. Okay. By using this reaction or comparison of this reaction, we can easily understood what is the main difference between these three reactions. Okay. Then write down this example. After that, we consider one another example. Okay. Then another example is consider CH3, CH3, H, CH double bond, CH2. It is a 3-methyl butene. This 3-methyl butene, it undergoes hydration, it undergoes HBO reaction, it undergoes OMDM reaction. Okay. In this example, alkene firstly. In this hydration, there is a formation of carbocation, and this product of this reaction is proceed or followed by according to Markovnikov's rule. According to Markovnikov's rule, the hydroxyl group is directly attached to the doubly bonded carbon atom, which carries less number of hydrogen atom. Okay. According to Markovnikov's rule, the hydroxyl group is attached to this carbon atom, But in this reaction, there is a formation of carbocation, and in this reaction, there is a rearrangement reaction is also shown. Okay. Then first we will consider the carbocation. Then this carbon also forms the carbocation. This carbon also forms the carbocation. Okay. There are two types of carbocations are formed here. Then CH3, CH, CH3. Then C plus CH. Then CH3 is also formed. There is a formation of secondary carbocation. After that, the carbocation is formed on this carbon atom. The positive charge is shown on first carbon atom. Then it forms CH3, H, CH2. There is again CH2 plus there is the formation of primary carbocation. Two different types of carbocations are formed, but in this secondary carbocation and primary carbocation, the stability of carbocation is more. Secondary carbocation is more stable than primary carbocation. In this carbocation, but in this secondary carbocation, the secondary carbocation is get converted into tertiary carbocation by shifting. This hydrogen is written here by shifting hydride. Or it is this process is known as A. In this process, the secondary carbocation get converted into tertiary tertiary carbocation by shifting hydride molecule or by shifting methyl molecule. That means in this step there is a 1,2 methyl shift is here. Therefore, there is a rearrangement reaction, or this step is a rearrangement step. After hydride shift, there is a formation of tertiary carbocation. CH2 then CH3. After formation of tertiary carbocation, the OH1s is linked with this tertiary carbocation. There is a formation of tertiary alcohol. There is a formation of tertiary alcohol. This is the main product of hydration of, and this is a primary carbocation. In this case, there is no arrangement reaction in form. Then this OH1s attacks on this primary carbocation, and there is a formation of primary alcohol. Okay, this is a important step in hydration of carbocation. In this step, there is a 1,2 hydride shift is shown here. 1,2 hydride shift. Okay. Then after that, in H2O reaction, in H2O reaction, the product of this reaction is proceed according to anti-Marconi fluid. That means the OH1 is attached to the doubly bonded carbon atom, which carries more number of hydrogen atom. But in this reaction, there is a no formation of carbocation, because of why there is a no rearrangement reaction is possible in this reaction. Then this reaction gives the product is CH2 and this is the main product of HBO reaction of 2-methyl-butene. Okay. In case of oxymercuration and deoxymercuration reaction, that is the OMDM reaction. The OMDM reaction, the alcohol is formed according to Marconi rule. But in this reaction, there is a no rearrangement reaction is possible, because in this reaction, carbocation does not form. Because of what? The positive charge is because of it does not formation of a positive charge. Therefore, according to Marconi rule, the hydroxyl is attached to the less number of hydrogen atom. Less number of carbon atom contains hydrogen. Okay. Therefore, this OH group is attached to this carbon atom. Then it forms a CH3, CH3, then CH. OH is attached to this carbon atom, then CH2 get converted into CH3. This is a product of this reaction. In between HBO and OMDM reaction, in HBO and OMDM reaction, there is no rearrangement reaction is possible. But in case of hydration of alkene, there is a rearrangement reaction is also formed. And after rearrangement, there is a formation of a alcohol by 1,2 hydride, or instead of 1,2 hydride shift, the 1,2 methyl shift is also shown here. Okay, for 1,2 methyl shift, this hydrogen is replaced by another CH3 group. After replacement of this group, this hydrogen is replaced by CH3, and after CH3, this methyl, it should be delocalized in between from this carbon to this carbon, or it is shifted on the adjacent carbon or carbocation. Then it happens 1,2 methyl shift. There is a one of the type of rearrangement reaction. After methyl shifting, there is a formation of this product. Okay. So guys, this example or 3,3-dimethyl-butene. It undergoes hydration of alkene, it undergoes HBO, it undergoes oxymercuration and deoxymercuration reaction. This example we consider for your homework. Okay guys, this is a preparation method of alcohol from alkene, and it is a comparison between these three important reactions. Okay guys, thank you.